All right, this is one of the funnest sections that you'll do, where you get to add rational expressions. Maybe subtracting are a bit funner, but adding, yeah, they're nice and challenging. Back in the old days, when we just had normal fractions like this to add, the rule was to add them, if they had the same denominators already, then you would just keep that same denominator. You don't change it, you don't multiply it, it's 7. And then you add the numerators. I could write it 1 plus 4, or I can write 5 over 7. That would be my answer. Similarly, when we have rational expressions, same thing applies. If these two denominators are the same, then I just leave the denominator the same, and I'll add what's up top. So I'll have 3 plus x. I would probably reorder the top one just so that it's in that descending order that we typically do. So that would be my answer. How about this one down below? Denominator is the same. I'll keep the denominator the same, x minus 1, and I'm going to take the top two things and I'm going to add them. Now, you might wonder why I put them in brackets. You'll see better why when we subtract polynomials. But putting things in brackets isn't a bad idea because I'm taking this thing and I'm adding that. I could have done that up here too, but there was only one term in each, so I just left it. If there's two or more terms, this isn't a bad practice to get into. Then I can drop the brackets, so I'll have 4x, take away 5, plus 2x, minus 1, all over x minus 1. And then if I add the x's together, I get 6x. Add this together, minus 5 minus 1 would be a minus 6, all over x minus 1. So that would be my simplification. I might, with this one, do one last thing with this. Because I just noticed on the top I can factor out a 6. And if I factor out a 6, I'm left with 6 times x minus 1 all over x minus 1. And notice now that I've got the exact same thing on the bottom and on the top. I could actually cancel those. And so my answer to the whole question, which is a little abnormal, usually I stop right there, but I just noticed you could factor that one again. So my total answer for the whole thing would be just plain 6. Now that is if the denominators are the same. If the denominators are not the same, then I've got to go through a little bit of a process. And it's probably just this number right there that you have to worry about. So if the denominators are different, you have to find the lowest common multiple, adjust each expression or each term, so that it coincides with the lowest common multiple. Then add the numerators, keep the denominator the same, and simplify if at all possible. Okay, let's try one. So here, I've got one where the denominators are not the same. So I have to find the lowest common multiple. What I did before is I would write the 16 and I would split it up, and that's never a bad idea. 4 times 4, and then each of those split into 2 times 2 times 2. So if my term is 16, the prime factorization of that is this. If I have 24, it would be 8 times 3, and 8 is 2 times 2 times 2. So 2 times 2 times 2 times 3, and a 24. To find the lowest common denominator, or the lowest common multiple, what I do is I take the most number of terms of each one. So 2's, there's 4 here, only 3 there. So in my lowest common multiple, I got 4 of them. 3's, none there, 1 there. So I just need 1 in my lowest common multiple. So the lowest common multiple will be 16 times 3, or 48. So over here, I'm going to take that 3x over 16, and I'm going to change the bottom number. Instead of a 16, I have to make it a 48. To do that, I multiply it by 3. Okay, and so it's going to come out to a 48 there. Now if I multiply the bottom by 3, I have to take that 3x and times it by 3 as well. So 3x times 3 would be 9x. Okay, so this term here now becomes this one down there. I was just using this as sort of an intermediary. If you can go right from there to there, fine. Okay, plus, let's do the same thing with 48, or with 24. So 24 has to get to 48, so I have to times it by 2, because I know I need to get to 48. But if I times the bottom by 2, I'm going to have to take this 5x squared and times it by 2 as well. So 2 times 5 is 10, so this will be 10x squared. Now that I have the denominators the same, I can add the numerators. So keep the denominator the same, add the numerators. I'm going to write 10x squared plus 9x. Notice that I just sort of rewrote them in the other order, just so they're in descending order. So that is my sum of that particular question. You get the concept? Hopefully you're getting the idea of finding LCM, adjust each expression or each term so it has that LCM, and then add them. Let's try a bunch more. Oh, here's one, x plus 1. So my term is an x plus 1 and an x minus 3. So the prime factor of that, you can't factor that, so the whole thing is just x plus 1. Same thing with this one, it'll just be x minus 3. So my LCD, there's one x plus 1, so that appears at most once. And there's one x minus 3. Again, that appears once. So this is my LCM, or LCD. So I need to change this, so it looks like that. So instead of x plus 1, it's going to be x plus 1 times x minus 3. Okay, I'm sort of skipping a step here. What did I do to this to get this whole thing? Obviously, I multiplied this x minus 3 there. So if I did that to the bottom, I've got to do that also on the top. And I still have that 3 out front. Good. Plus, this one has to change to this denominator right there. So x plus 1 times x minus 3. So what did I do to the bottom to get this? It looks like I multiplied by an x plus 1. So if I did that on the bottom, I've also got to multiply the top by that. And I still have the 5 there. Now I have the exact same denominator, so I can just write it by itself. X plus 1 times x minus 3. And then I can add the top stuff. So I'll have 3 times x minus 3 plus 5 times x plus 1. Now simplifying, I'll use the distributive property. So 3x minus 9 plus 5x plus 5 over, I'm just going to keep that denominator like that. It looks good as it is. I'll just keep it like that. Okay, now I'll add the x's. That would be 8x minus 9 plus 5 would be a minus 4 all over x plus 1 times x minus 3. Okay, you may want to pause and go back through that just to make sure you're catching each step. I've got 2 or 3 more questions to try though, and hopefully you'll get them as we keep going. Alright, here's another one. Maybe try this one. See if you can do it, and then come back. Okay, so my first term is x plus 3, and I can't factor that anymore. I just leave it. Same thing with the x plus 8. It's already in a prime factor, so I leave it. So my lowest common denominator will be x plus 3 times x plus 8. Once you get onto these, they'll go fairly quickly. So this term here, I need to change so it has an x plus 3 and an x plus 8. Okay? It started with an x minus 2, and so the bottom one started with an x plus 3. I added this x plus 8 in there, and so if I did it on the bottom, I also have to do it on the top. Okay, now let's do the next one. So I started with an x plus 8 and an x plus 7. I'm going to try and use my colors a bit better here. And so the denominator has to have an x plus 3 on the bottom. That's different than the original one. So if I do it on the bottom, I must do it on the top. So this and this are equivalent expressions. Okay, now my denominator is the same, x plus 3, x plus 8, x plus 3, x plus 8. So I can write x plus 3, x plus 8 on the bottom, and then on the top, I'll have x minus 2 times x plus 8 plus x plus 7 times x plus 3. So I do the same thing as I've been doing with the other ones. Now on the top here, you look at it and you get all excited because you get to do a bunch of FOIL, eh? Let's try that. So this will be x squared plus 8x minus 2x would be minus 6x. Notice I do that middle term in my head. Minus 2 times 8 minus 16. Plus x squared plus 3x plus another 7x, so that's plus 10x, plus 21. All over x plus 3 times x plus 8. Now let's just collect like terms on the top. X squared and an x squared, that would be 2x squared. Minus 6 plus 10 would be up 4x. And then minus 16 plus 21, that looks like it's plus 5. So that's the numerator all over my denominator, which is x plus 3 times x plus 8. So that is my sum if I were given this as my question. Again, you might want to pause and go back and make sure you're catching each little part. Let's try another one. Oh, nicer denominators. So I have an x cubed minus x, and I have an x squared plus 2x plus 1. Well, this bottom one, that's just a normal one. So it's x and an x. Two things that multiply, 1 add to 2, it will be 1 and 1. There we go. So there's 2x plus 1. Now this top one, x cubed minus x, I can factor an x out, and then I'm left with x squared minus 1. But then this x squared minus 1, that's a difference of squares. So I can change that to my two brackets, x minus 1, x plus 1. Okay, now let's see what my lowest common denominator will be. I have 2x plus 1, so I need two of those, x plus 1 and an x plus 1. Up here I need another x, because it's by itself. X minus 1, I don't have one of those yet, so I need an x minus 1. X plus 1, I already got it. So there's my lowest common denominator. Whew. So let's rewrite this. I've got 3 over, I'm just going to factor that out like I had it here. So x minus 1, x plus 1, plus 4 over x plus 1 times x plus 1. Okay, so let's look at this and compare it with my lowest common denominator. What's different? It looks like I need another x plus 1. So let's put an x plus 1 down there. Okay, now it's my lowest common denominator. But if I did it there, I got to put it up there. Okay, now let's look at the next one. I have two x plus 1s. I have those, but I don't have these. So I have to put those up top here. So x and an x minus 1. There. Oh, I forgot I have to put this x and the x minus 1 at the bottom. Okay, my denominators are the same, so now I can write the whole thing over one denominator, x times x minus 1 times x plus 1 times x plus 1. You could do a squared thing here if you wanted, if you have two, but I like writing them out. Okay, now let's go and let's FOIL this stuff. So that would be 3x plus 3. And then here I've got 4x squared. And 4x times a minus 1 is a minus 4x. Okay, simplifying, let's gather like terms. It looks like 4x squared is the top dog. 3x minus 4x would be minus 1x plus 3. All over x times x minus 1 times x plus 1 times x plus 1. Done. Ooh, that's a lot of work. Lots of work. You get the concept? I got to get a common denominator. Typically, you're going to factor those bottom things first. And then once you have the lowest common denominator, make sure you take a look at what it started with. And if there's anything changed that you multiply those on top and bottom. And then simplify. Okay, I think I have one or two more to try. Oh, here's a good one. X squared plus 17x plus 16. So I need to factor that. Two things that multiply to 16 add to 17. Well, it has to be x plus 16, x plus 1. Okay, x squared plus 9x plus 8. Oh, this one's similar. X plus 8, x plus 1. So my lowest common denominator, x plus 16, occurs at most once. X plus 1, it occurs at most once. X plus, that was an 8. X plus 8 occurs once. So there's my common denominator. Okay, let's rewrite these. 5 over x plus 16, x plus 1. Okay, plus 3 over, this was x plus 8, x plus 1. Okay, so how is this different than the, how is this different than the lowest one? This one doesn't have an x plus 8, so I need to have an x plus 8 there. If I do it on the bottom, I need to also do it up top. Okay, how's this one different than this? There's no x plus 16, so I need to put an x plus 16 there. If I do it on the bottom, I need to do it on top as well. Okay, so I have lowest common denominator. Let's just write it out. X plus 16, x plus 1, x plus 8. Notice that the order of those binomials, because I'm multiplying, doesn't matter. That's your associative property. Okay, and then on the top, I'm going to have 5x plus 40. Just doing my distributive property there. Plus 3x plus whatever 3 times 16 is. Okay, then I gather my like terms on the top. 8x, 40 plus that would be plus 88 over that whole denominator. X plus 16, x plus 1, x plus 8. Now this top one, whoops, this top one looks like you can also factor that. Like I can factor an 8 out. But if I get x plus 11, that's not going to cancel with anything on the bottom. And so at this point here, I think I'd be okay if you stop right there. If you go to here, that's good too. I might give you a happy face if you go that far. But if you get to this point, I'm perfect. Okay, let's try just one or two more. Oh, this looks like a different one. These are pretty close to the same thing, but the sign's different on this one. Let me just show you a quick little trick to fix that. So if you have the exact same thing, but the sign's different, what you can do is take that one that you want to make the same and just multiply both the top and the bottom by -1. So this will be x over 4 plus 5 times -1 would be a -5 over -4 times -1 now is a +4. That's just a quick little trick. And so denominators are the same, keep it 4, and on the top I'll have x plus a -5 or x minus 5. Okay. Oh hey, this one's sort of the same. It's just flipped around. Let's try that same thing. Let's try multiply this by -1, multiply this by -1. So I'll get 2x plus 1 over x minus 3 plus, this will be, I have to do the distributive property, so it'll be -x minus 2, that's what this will, the signs change, over, this will be a -3 plus x. Now, if I rewrite these in the proper order, I'll just write the whole thing again. Plus -x minus 2 over, this will be x minus 3. Now notice that they're identical. The denominators are the same. So now I can just add the top. So it'll be 2x plus 1 minus x minus 2 all over x minus 3. Collect like terms on the top stuff, so it'll be x minus 1 all over x minus 3. That will be my simplification of that one. Okay, one last one, and then we'll call her good. I'm giving you lots of examples of these, and you may want to come back and review them. So x squared minus 16. To factor that, that's x minus 4, x plus 4. 12 minus 3x. I think I can take a 3 out. Why don't I take a -3 out? If I take a -3 out, I'll be left with a -4 plus x, right? Or a negative 3 and x minus 4, right? If I just switch those around to the right order. Okay, so now let's look for a common denominator. I've got 1x minus 4. Here I have 1x minus 4, so that's part of it. I have an x plus 4, nothing down there, so an x plus 4. Here I've got a minus 3. There's just one minus 3, so a minus 3 will be part of that denominator. Okay, so this one was x plus 3 over x minus 4, x plus 4, plus, and this one is 5 over, I did that whole factor and I came up with that, so it'll be minus 3x minus 4. Okay, now I'll take, and how is this different than this one? This one has a minus 3, so I need to put that there. If I do it there, I need to also do it up top. And it's going to be multiplied by both of those, so maybe I should put those in brackets. Okay, this one, how is it different than this one? Looks like this one doesn't have an x plus 4. So I need to put one there, and of course one up top. Now I've got a common denominator. I can write the whole thing over the one denominator. So minus 3, x minus 4, x plus 4. Then here I'll FOIL, or distribute that through, so it'll be a minus 3x and a minus 9. And then plus 5x plus 20. Okay, now we'll keep the bottom the same, x minus 4, x plus 4. And the top, minus 3x plus 5x, so it would be a 2x. Negative 9 plus 20 would be a plus 11. So this would be the sum of that there. Lots of intricacies in these questions, lots of places where you can go wrong. Very important to follow a methodical way of doing it. Sort of like I showed here. Show your factors over here, get your lowest common denominator, put that in, see how it changes, and then work with it there. Do lots of practice. If you have questions, please send them to me. I'd love to help you.